Hi guys, this is Dr. Gonzalez, and in this video I'm going to discuss with you validity and how it applies to experimental research. And this information is based off the Moorling textbook, and it primarily comes from chapter 3 because there is a separate section around chapter 5 and 6 where we get into actually delving into the specific validity that we prove using experiments. So let's talk about the different kinds of validities. So I have an image here that's showing you the classic bullseye target comparison of things that are reliable and valid. And I'm not going to get into reliability so much with this particular presentation. There is some of that information covered in the measurements video, but for now we're just going to focus on validity. So I want to make sure that you've read chapter 3, even though part of it is not necessarily focused on experimental research. You still need to know about the 4 different types of validity. And when you write your proposal paper for this class, you're going to need to make sure you address each of the 4 types of validity. So that's one of the reasons why I wanted to review with you all of them before we get into the things that are specific to experimental research. So in the book, there are 4 validities that help determine with confidence how much faith you should put into your research findings. Those 4 validities are construct validity, external validity, statistical validity, and internal validity. Internal validity is going to be the one that we focus on because it has to do directly with causal claims. Construct validity focuses on how well a variable was measured or manipulated. So if you'll recall from our previous conversations and videos, we talked about an operational definition. And that operational definition takes a theoretical construct and it turns it into something that I can measure. And that measurement needs to be reflective of that operational definition, and it also needs to be something that I can confidently measure. So you're asking the question with construct validity, are we measuring what we think we are measuring? So a lot of times in psychology, we deal with variables that are very abstract. Stress, intelligence, happiness are some examples. So we've got to be able to translate them into something that is measurable, and it's got to be understandable by other people. Construct validity is going to tell you if you did that well. When you're evaluating construct validity in research, you're asking 3 questions. Does this measure actually capture the concept? So I have this concept out there like sleep quality. And I come up with a tool like the PSYC, the Pittsburgh Sleep Quality Index, and I call it a measure. I want to know if that measure is actually capturing the concept. So if you go and you pull the PSYC, you'll see there are a lot of different dimensions related to sleep on there. It doesn't just focus on one subjective question, how well do you sleep? It brings in data from a lot of different sources, or not data from a lot of different sources. It asks for participant data on several different aspects of sleep. That together provides us with a measure of construct validity because I'm not relying on one single thing, and that measure is actually capturing the width and the depth of the concept. We also want to make sure that the operational definition is appropriate, and by that we mean that we're actually asking about the concept at hand and not some other variable that has nothing to do with what you're talking about in your research. I believe there was an example in the book with some questions about life satisfaction, and one of the questions asked about polka dots. That's not necessarily anything related to life satisfaction, so it's not really appropriate in that particular situation. And then the third question is the manipulation a good representation of the construct? So I can manipulate things, but that level of manipulation that I give has to be a good representation of the construct. If the manipulation is not valid, It's not going to measure what you're actually attempting to measure. So an example from Morling about construct validity was about the study claiming that children that pretend to be Batman increase their persistence. And this is task persistence. So in other words, not giving up at a particular task. So in that study, we have to ask, if the task I'm asking the child to do, does it actually measure persistence? It could measure something else. So we need to make sure that we're getting at persistence because that's what we're trying to study. The other question it asks is, does wearing a costume truly represent being a hardworking hero? And that one to me is a lot harder to digest because a hardworking hero is something that is difficult to conceptualize to begin with. So you have to ask yourself those questions because if your construct validity is weak, your entire study can be called into question because you may not be studying what you think you're studying at all, and any results that you get from that study are going to be misleading at best. Even if you carried out the best research study in the entire world, it really isn't going to mean much. So moving to the next one, we're going to talk about external validity, and this one is one of the easiest ones to conceptualize. External validity relates to the concept of generalizability. It's a tough word to pronounce, but we're basically just asking to whom or what can I generalize these results. Remember, we take a sample from a population when we're doing research. And you can have a study that is perfectly conducted, but it's still going to be limited if that study can't apply outside of your research perspective. So if it only focuses on a very narrow group, and it doesn't extend to real-world settings, it's going to have low external validity. So when you are evaluating external validity, you're going to ask questions such as these. Does my sample represent the population? Can results generalize to other groups? And do findings apply in real-world situations? So sample representing the population can be increased by increasing your N, right? Because the more people we include in our sample, the closer we get to that actual population there. Can your results generalize to other groups? So if I do a study in the United States about teenagers and electronic devices related to their sleeping satisfaction and duration, is that going to generalize to teenagers in France or in Canada or in Australia? And then the third one is, do findings apply in real-world situations? So this might be important with lab experiments. Maybe I do a research study using an experimental method and I'm using mice in a Morris water maze. And I'm looking at visual cues on the wall and some variable like sleep deprivation. Is that going to apply to people? So it's great in a lab. It's wonderful. You can control lots of different variables that you don't have that level of control over in the outside world. But it can also limit my external validity. So I need to keep that in mind when I'm doing this experiment, collecting the data, and then trying to generalize it to another situation. So the example from Morling was if I studied 6-year-olds in Minneapolis, I want to ask myself questions like, is this going to apply to 12-year-olds? Is it going to apply to children in France and then in other contexts? So without external validity, your findings could be super on, they could be accurate, but they would be useless outside of the context of your particular research situation. Statistical validity evaluates how well the numbers back up your claim. So it's going to focus on the strength, precision, and reliability of your results. And you're actually asking the question, do my data support my conclusion? So you could have well-measured variables, and they could be generalizable, but still have an incorrect conclusion if your effect is weak, your estimate is imprecise, or the results are due to chance. And those three things are going to be covered in depth in my hypothesis testing video that you'll watch later on. What do you ask when you're evaluating statistical validity? You're asking questions such as how strong is my relationship or difference, and that's getting at the concept of effect size. You're also asking about how precise your estimate is, and that gets into confidence intervals. And the third one has to do with the ability to replicate your study. So we want to be able to replicate studies and get the same results. That provides more statistical validity to your original study if your results have been replicated. Here's an example that goes back to that situation in Morling's book about persistence. So if I have two groups of children and one group persists at a task 60% of the time and the other group only 35% of the time, I want to know if that difference between 60 and 35 is large, right? It could be statistically significant, but does that have any real-world application? So I'm going to look at power and effect size. I want to know if my estimate is precise. That has to do with, our distribution means and the probability of finding a statistical significant level on our study and our research statistics that we're running. Did it fall in that critical area? Did I make the right decision? Did I retain the null, or did I fail to reject? We also want to know if that research has been replicated and the same results have been found repeatedly. Poor statistical validity is going to lead to false positives and false negatives. False positive is when you claim that there is an effect that really doesn't exist, and false negatives happen when you claim there's no effect and you actually missed it. We also want to use caution with overinterpreting weak or noisy data. Now, this brings us to internal validity. And internal validity is the crux of an experiment, because internal validity is causation. And causation is based on whether or not your study can successfully rule out any alternative explanations. So you're asking the question, can I confidently say that variable X causes variable Y? Now, to be able to claim causation, your study has to show that first, covariance existed. X and Y were related. And we do that through statistics, and it's often based, our experiment's going to be based on the idea that somebody probably already did some sort of study that showed that those two variables were correlated. Remember, correlation doesn't imply causality. So to take it to the next level, I need to do an experiment. You also have to have temporal precedence. Temporal has to do with time. And in temporal precedence, variable X has to occur before variable Y. In other words, I can't claim that X causes Y if X didn't come before Y. And then the third one, which is the one that's going to be probably the most difficult to achieve, is you have to have excluded all alternative explanations that exist out there. The explanation that you're claiming has to be the only explanation. You have to have ruled out all the other alternatives that exist. So internal validity specifically refers to that third condition, ruling out all the confounds. So when you're assessing internal validity, you're going to ask questions like, first, is this an experiment? And since this class is about experiments, that's what we're going to be focusing on. So assuming that something is an experiment, we have to go into a deeper conversation. Did I use random sampling, random assignment? That helps distribute any variance between my participants across all of my groups. I also have to ask about confounds. Is there another variable out there that could be having an effect? We discussed moderators in a previous video. We also discussed extraneous variables. I've got to be able to control for the things that I am anticipating and then recognize extraneous variables in there when I am talking about that causative relationship. And I also have to ask a question that there possibly could be something else explaining those results, and I have to rule that out. So it's very important that you recognize that internal validity is only going to be relevant for causal claims, and the only way to prove causal claims is through an experimental design. So without internal validity, you can't make a causal claim, and you're left only with correlation, and correlation can't be used to assess causation. That's the end of this video. It was kind of short. I know if you've taken my 4370 class, we go into this a lot more in detail because 3 of the validities that we discussed here are not related to, I'm sorry, I apologize. The 4th validity, internal validity, there we don't discuss that in causation. But I just kind of wanted to highlight the idea that all of the 4 validities still apply here, and internal validity is very important in our experiments. This video is going to work together with some of the other videos that I'm putting together for this particular module. So make sure you've watched them all before you tackle any of the assignments. Check Canvas for instructions, templates, and any videos that are related to this week's assignment. Thanks for watching.